Cool. Let's keep going. So, the next equation I need to teach you is concentration and how we calculate concentration. So if you guys remember, last week we were looking at the moles to mass and how to convert from moles to mass with that N equals little m over big M. So that's the first step that you're going to have to do in a lot of your calculations. The second step you're going to have to do in a lot of your calculations is using concentration. So just so you guys are aware of what the concentration equation is, concentration is equal to N divided by V. You might also see it being concentration equals little m over V. It's just a slight variation how we're referring to concentration. C in both cases are referring to concentration. V in both cases is referring to volume. So what I'm thinking about in those examples is how much solid am I dissolving into a liquid? So if I'm dissolving a lot of solid into a little bit of liquid, then it's very concentrated. If I'm only dissolving a little bit of solid into a lot of liquid, then it's very dilute. It's just that sort of thing. And I'll switch over to the PowerPoint just so you guys can see what I'm talking about. We're just talking about this here. Okay? Keep going. All right, there's two different types of concentration we might be referring to. In this case, that one is moles, and this one with the little m is referring to mass. So you might see concentration being referred to as moles per liter. In this example, it would be grams per mole. Both of those are types of concentration. Which one do you think we're going to use more often? Moles per liter, because like we were saying before, we want to be able to talk about quantities and comparing and contrasting those quantities. So if I'm using grams, things have different weights, so I can't compare two things that have the same grams. Whereas if they have the same moles, then I know they have the same amount of particles. So this is the one we will primarily be using. Are we good so far? All right, shall I show you some examples using it? Okay. So here in our first example, we did a calculation and they said, what is the concentration? We want it in moles per liter. If 2 grams of sodium carbonate is added to 0.1 liters of water. So 0.1 liters of water is equivalent to 100 milliliters of water if I was doing that conversion. So I already have my moles. So if I want to figure out concentration, I would do N divided by the volume. So when I start substituting in my numbers, concentration is equal to 0.01887 moles, and I'm dividing it by my volume, which is that here, 0.1 liters. And what I can then find by doing that is the concentration of that solution. And so my concentration is 0.18. I'm going to round it up to 9 moles per liter. So that's how I figure out concentration. Are you okay with that so far? All right. Now I need to show you guys how to go the other direction. So this is going from, I have mass dissolving into solution, what's the concentration? This one is basically going backwards. I know the concentration of my solution. I know the amount of solution I have. What's the mass that I need to add to make a solution of that concentration? Does that sound good? All right. So what I first need to do is I'm going to start going backwards. And I know that my concentration is equal to N divided by V. I have my V right here. I have my concentration right here. Are you okay with that so far? First thing I need to do is rearrange the equation because I need to figure out the amount. So again, just like you guys did previously, we multiply each side by V. So that way the V's cancel out and I get N by itself. So N is going to equal my concentration times the volume I'm using. So N equals, concentration is 0.64 moles per liter, and I'm multiplying it by 0.250 liters. Do we see how the liters cancel out? And I'm left over with moles. So that's a good way to double check that you've done the right thing. So 0.164 times 0.25, I get, oops, I forgot to put the point in that. 0.64 times 0.25 is 0.041 moles. Are we okay with how I found that? All right, obviously with that, I can't go and count up those atoms to figure out then what's going to give me 0.041 moles. So what I'm going to do is convert it into a mass. That way I can just go onto my scale and weigh it out on the scale. Now before I'm able to do that, I need to convert this back. So we are going to need to use that N equals M divided by big M. So again, we rearrange the equation to solve for the little m. So little m will equal N times the big M. Now I know what the little n is because I have. All right. Are you okay with that so far? All right. So I need to figure out what the big M is. So in most cases, we will give you the big M. You don't have to worry about calculating it. But if you were to calculate what big M is, remember you're looking at the formula here. So C7H6O2. So for the C7, I have 12 times 7, because I'm taking the masses. The hydrogen, which is 1 times 6. And then the oxygen, which is 16 times 2. Those are the atomic numbers. I'm taking them off of the periodic table. Are we okay with that so far? It is recording. Don't worry, it's recording over here. You're okay. It's okay. You guys are very panicked. All right. So 12 times 7, 84, plus 6, plus 16 times 2 is 32. So my total mass is 122. Are you okay with that? So that here is my big M. So I have my little m now. I have my big M. So I can plug in my numbers. Mass equals 0.041 moles times 122 grams per mole. The moles cancel out, which is good because it tells me I'm going to go and just have grams. And so my mass is going to be basically 5 grams. So if I weighed out 5 grams of that chemical, that would then, and mix it into 250 milliliters of water, I would get that concentration. Are we okay? All right, moving on. All right. Move it. Good. All right, so we're gonna move on, and what I want you guys to do is some practice questions. So I'm gonna stop the recording on this.